This class we have taught 8 problems. First problem is the maximum demand on the station is 150 kilowatts. The annual load factor is 50%. Calculate the total energy generated in a year. Total energy generated in a year is equal to maximum demand into load factor into hours in a year. Maximum demand is given 150. Annual load factor is given 0.5. Hours in a year is 8,760. Therefore, energy generated in a year is 6,57,000 kilowatt hour. Second problem is a power station is to supply peak loads 10,000 kilowatts, 8,000 kilowatts and 7,500 kilowatts. The diversity factor of the load is 1.5 and the average load factor is 0.6. Calculate maximum demand of the station and annual energy supplied by the station. Maximum demand of the station is equal to sum of the maximum demand, that is peak loads, divided by diversity factor. So 10,000 plus 8,000 plus 7,500 divided by 1.5. So maximum demand of the station is 17,000 kilowatts. Now we can calculate average load. Average load is equal to maximum demand into load factor. Maximum demand is 17,000 kilowatts. Load factor is 0.6. Therefore, average load is 10,200 kilowatts. Next, we have to calculate the annual energy generated. Annual energy generated is equal to average load into hours in a year. Average load is 10,200 into hours in a year, 8,760. 89,352 into 10 power 3 kilowatt hour. That is the annual energy generated. Third problem is a generating station has consumed a load of 15 megawatts and maximum demand of the station is 25 megawatts. A unit generated being 60 into 10 power 6 per annum. Calculate demand factor and load factor. Demand factor is equal to maximum demand divided by connected load. Maximum demand is given 50, connected load is 25. Maximum demand is 25, consumed load is 50, 25 by 50 is equal to 0.5. Average demand is equal to units generated per annum divided by hours in a year. That is the average demand. This is given 60 into 10 power 6, that is the unit generated per annum. Hours in a year is 8,760. Average demand is 6,849.32 kilowatts. Now we can calculate load factor. Load factor is equal to average demand divided by maximum demand. Maximum demand is 25 megawatts. That is average demand is 6,849.32 kilowatts. Therefore, load factor is equal to 0.27 or 27%. Fourth problem is a power station has a maximum demand of 20,000 kilowatts. The annual load factor is 50%. Plant capacity factor is 40%. Determine the reserve plant capacity. So, energy generated per annum is equal to maximum demand into load factor into hours in a year. MD is given 20,000, load factor is given 0.5, hours in a year is 8,760, energy generated per annum is 87.6 into 10 power 6 kilowatt hour. So that is the energy generated per annum. Next we have to calculate the plant capacity. Plant capacity factor is equal to unit generated per annum divided by plant capacity factor. Plant capacity factor is given 40%. Therefore, unit generated per annum is 87.6 into 10 power 6 divided by plant capacity factor 0.4 into hours in a year 8,760. That is equal to 25,000 kilowatts. That is the plant capacity. Reserve plant capacity is equal to plant capacity minus maximum demand. So plant capacity is 25,000 kilowatts. Maximum demand is 20,000 kilowatts. Reserve plant capacity is equal to plant capacity minus maximum demand. That 25,000 minus 20,000 is equal to 5,000 kilowatts. That is the reserve plant capacity. Problem number 5. A generating station supplies the following loads to various consumers. Number 1, industrial consumer is equal to 1000 megawatts. Number 2, commercial establishment is equal to 500 megawatts. Number 3, domestic power is equal to 10 megawatts. Number 4, domestic light is equal to 15 megawatts. Maximum demand is equal to 1000 megawatts. And units generated per annum is equal to 50 into 10 power 5. Calculate diversity factor and annual load factor. Diversity factor is equal to sum of the individual maximum demand 1000 plus 500 plus 10 plus 50 divided by maximum demand 1000. Diversity factor is equal to 1.56. Average demand is equal to unit generated per annum divided by hours in a year. Unit generated per annum is given 50 into 10 power 5 divided by hours in a year 8760. Average demand is equal to 570.78 kilowatts. The last is annual load factor is equal to average load divided by maximum demand. Average load is 570.78, maximum demand is 1000, annual load factor is 0.57 or 57%. Sixth problem is a 100 megawatt power station delivers 100 megawatts for 3 hours, 50 megawatts for 5 hours, and is shut down for each day. It is also shut down for maintenance for 50 days each year. Calculate annual load factor. First we have to calculate energy supplied for each working day. So 100 into 3, 300 plus 50 into 5, 250, 550 megawatt hour, that is energy supplied for each working day. Station operates for year, that is 365 days, 50 days for maintenance, 365 minus 50 is equal to 315 days in a year. We can find energy supplied per year. That is energy supplied for each working day is 550 into 315, 1,73,215 megawatt hour. Annual load factor is equal to megawatt hour supplied per annum divided by maximum demand into hours in a year. Annual load factor is equal to 1,73,250 by maximum demand is 100 given into hours in a year 315 into 24. Annual load factor is 0.229 or 22.9%. Seventh problem, determine the value of a load which consumes 500 kilowatt hour per day at load factor of 0.45. If the consumer increases the load factor to 0.65 without increasing the maximum demand. Question is, calculate the consumption of energy in kilowatt hour. First we calculate load factor is equal to energy consumed in 24 hours divided by maximum demand in kilowatts into 24. So energy consumed in 24 hours is given 500 divided by maximum demand. We don't know, we have to calculate. Load factor is given 0.45, 500 by MD into 24. So MD is equal to 500 by 0.45 into 24. Maximum demand is 46.30 kilowatts. Again, next we have to increase the load factor to 0.65. So energy consumed in 24 hours is equal to load factor into maximum demand into 24. So load factor is 0.65 into 46.30 into 24. So energy consumed in 24 hours is 722.28 kilowatt hour. Last problem. A power station supplies the peak loads 30 megawatts, 25 megawatts and 35 megawatts to 3 localities. The annual load factor is 0.6 and diversity factor of the station is 1.65. The question is, calculate number 1 the maximum demand of the station, number 2 the installed capacity of the station, number 3 the energy supplied in a year. First we calculate the diversity factor. Diversity factor is given 1.65. So sum of the individual maximum demand divided by maximum demand of the station, that is a diversity factor. Here we have to calculate the maximum demand of the station. So this is 1.65, that is equal to sum of the individual maximum demand 30 plus 25 plus 35, that is equal to 90 by diversity factor 1.65, that is equal to 54.55 kilowatts, that is the maximum demand of the station. Next, installed capacity is equal to 30 plus 25 plus 35, that is equal to 90 megawatts. Next we calculate average load is equal to load factor into maximum demand. Load factor is given 0.6. So 0.6 into maximum demand 54.55, that is equal to 32.73 megawatts. The last is we have to calculate energy supplied per year. that is equal to load factor into maximum demand divided by diversity factor into 8760. So the load factor is 0.6, maximum demand is 54.55, hours in a year is 8760, diversity factor is 1.65. Therefore, energy supplied per year is equal to 1,73,766.54 megawatt hour. Thanks for listening.